Hi friends, welcome to Devrat Knowledge Villa. You are watching our English video series of operating system and learning memory management. Today's our topic is address translation. Before starting the address translation, we have discussed little bit about the memory management. Whatever the number of instructions stored into the secondary memory, those number of instructions we are bringing into the main memory. So that's why there is need to translate the address. So there is need to translate logical address into the physical address. This entire concept, why we are bringing those number of instructions from secondary memory to main memory, these things we have already explained into our introductory series of memory management. So you guys, if you please remind to watch that video of introduction of memory management, so you can click here on top of the right corner and you can watch the video of memory management. So then after you will be better understand the address translation. Let's start with the address translation. What is happening? Actually we have a large amount of storage in our system, probably 1 TB to 500 GB, and we have a as compared to secondary storage, we have a little bit small main memory. Probably in today's configurations we are using 8 GB or 12 GB main memory. So whatever the data was available inside the secondary storage, so it is difficult to search due to the high amount of memory. But we can search those number of data from the main memory very faster because memory amount is little bit small. So whenever CPU is accessing the data, so CPU accessing data from the main memory. But actually where data arrives into the main memory, so data arrives into the main memory from the secondary storage. So this thing all about the memory management and address translation. Whenever we store any program or any data inside the secondary storage, like we have stored program P1, so these are the line of codes. It means number of instructions are there, n number of instructions are there. So we are going to store this all n number of instruction here into the main memory. Suppose we want to execute this program P1, so we have to bring this entire program P1 into the main memory for the execution. Whereas when program was actually stored into the secondary memory, so it is stored with the logical address. So whenever CPU is searching about that program or that data, so CPU always generating a logical address. But whenever we bring this entire program for the execution inside the main memory, so that program becomes process and address is going to be changed from secondary storage to main memory. So right now wherever the program is physically present, that is the physical address of that particular program. So there is need to translate logical address into the physical address. There is the main fundamental of address translation. Let's see how this thing is occurring. CPU is bringing the data from the main memory, yes, and main memory is bringing the data from the secondary storage. Suppose inside the secondary storage, there is a number of instruction, n number of instructions are stored in any program, and this starting address is from the I inside the secondary memory. So first instruction is started from the I plus 1, from starting point of memory up to this moment. This I instructions are already stored inside the secondary storage, and now we are going to store one more program with the n number of instructions. So our program will start from the I plus 1, then after next instruction would be I plus 2, and so on up to the I plus n. Whenever we are bringing this number of instruction into the main memory, suppose we are bringing this instruction into the main memory. So when this program was into the secondary storage, so before that program I number of instructions were actually stored, starting address was I. But inside the main memory, whatever the number of instructions stored before this program, it is not necessary those number of instructions are stored up to the I. Maybe it should be different. Guess look like up to the J number there is a number of instruction is stored. So we have to start our n instruction from the J. It means J plus 1, J plus 2, J plus n, where actually it was started from the I plus 1, I plus 2, and whenever we are going to store, so address is going to be changed. It is started from the J, J plus 1, J plus 2, and so on. So whenever CPU is start searching, so it will start searching from the I plus 1, and whereas actually data is stored at a J plus 1. So there is need to convert this I plus 1 address into the j plus 1. This thing is actually address translation. So let's see how we can do this. So for accessing the data from the j plus 1, what we will do, let's see, we will use two things. One is limit register and another one is relocation register. Inside the limit register, total number of instructions are going to be stored. Look like how many total number of instructions are over here in our program. So there are n number of instructions are there. So we will store n inside the limit register. And another register is relocation register. So whatever the number of instructions are going to be start, so we will store the starting address inside the relocation register. So instructions are going to be start from the j plus 1. So that's why we will store j inside the relocation register. And what we will do, CPU will generate the required number of instructions. Suppose CPU is generating any number of instruction outside the n. So it will compare with the limit registers. If generated request is less than or equal to n, because we have stored only n number of instruction in our program. So if CPU is generating greater than instruction greater than n, it means CPU generating n plus 1 or n plus 2. So it will not be possible to search inside this program, because if CPU will request n plus 1, so it will point to the some another program and it will be a wrong access. Get it? So that's why we are going to store the limit register with the n. Get it? So CPU can request only number of instruction up to the n. If CPU will generate more than n instruction, so it will be trap. Get it? So whenever request is less than or equal to n, it means CPU is requesting 1 to the n instruction. So then and then request is going to be ahead. Get it? And after reaching here, we will make a sum request plus j. It means our starting address is from the j. So we will make j plus something, like CPU is accessing first instruction. CPU is request for the first instruction. So it will request with the 1. So 1 less than equal to n or not. So if n instructions are there, so 1 less than equal to n. So it will go ahead and it will going to be sum inside the relocation register here. So it will add the j number of instruction here. So 1 plus j. Get it? So directly it is going to be point first instruction j plus 1. Let's see with the example so you can understand in better way. Like CPU is requesting any kind of program, like we have a program with the number of total 50 instructions over here inside the secondary storage, and we are bringing this entire program into the main memory. So here starting address, whatever the starting address was there inside the secondary memory, this starting address is going to be changed again inside the main memory. So suppose before storing this program, actually already 12 instructions are already stored inside the main memory. So after this starting address 12, we are going to store our more 50 instruction inside the main memory. So what will happen? Our starting address is 12. Get it? So that we have to remind. Let's start searching. CPU is searching instruction number 33. Get it? So we have stored 50 instructions. Out of 50 instructions, we are looking for the 33rd instruction. And the limit register, whatever the number of total instructions are there, that we have to store inside the limit register. Get it? So we will store 50 inside the limit register. So when request arrives here, so it will check with the limit register 33 less than or equal to 50 or not. Yes, obviously 33 is less than or equal to 50. So it will not going to be trap. If suppose request is 53, in place of 33 request was 53. So what's happened? 53 less than equal to 50? No. So it will going to be trap. Get it? But right now request is 33. So 33 less than equal to 50. So it will go ahead and compare with the relocation register. Relocation register will add its own value. What is the starting address? Starting address is 12. So we will store 12 into the relocation register. So 12 is again going to be added into the 33. So it will make the summation 33 plus 12. Get it? And then after this instruction is going to be fetched from the main memory. So actually which instruction is going to be fetched? It will fetch the instruction number 45, because 12 instructions are already available before our program, and we are looking about the 33rd instruction 33rd instruction of our program. So earlier 12 plus 33, so our instruction number 33 is going to be stored into the main memory at a position of 45. So whenever CPU is searching 33rd instruction, so main memory will allocate the 45th instruction. So it will be our real search. Get it? So this thing is known as the address translation. Actually this entire program was stored inside the secondary memory. We are bringing this entire program into the main memory, and again starting address is going to be changed. So right now it is our physical address. So CPU always generating the logical address. So 33 is logical address and 45 is a physical address. So whenever data is going to be accessed, so it is converted into the physical address, whereas CPU is searching with the logical address. So this 33 is going to be converted into the 45. This thing is known as a address translation. Hope you are understanding very well. If you have any query regarding to the address translation, you can write your query into the comment box. I will try to solve out it with my best. Thanks for watching Devrat Knowledge Vilya. Thank you once again.